Example 10, finding the inverse of a function using reflection about the identity line. So given the graph f of x in figure 9, we want to sketch a graph of f of inverse of x. In order to sketch that, we need to first look at the points on this graph that we can clearly see. So the points that we can see are 1, 0, 2, 1, and 4, 2. Now the inverse, the inverse is inverting these points. So now f inverse of x becomes 0, 1, 1, 2, and 2, 4. So now we're going to go ahead and then graph those on that line. So we're going to plot 0, 1, 1, 2, and 4, 2. And you can see this is what that graph looks like. And now, going back to our previous slide, you can see that y equals x represents the identity line, which is the line of symmetry for these two lines. Because if you folded this, that means these two graphs would be right on top of each other. So this is a one-to-one function, so we were able to sketch an inverse. Note that the graph shown has an apparent domain of 0 to infinity and a range of negative infinity to infinity. So the inverse will have the domain of negative infinity to positive infinity and the range of 0 to infinity. And what we saw was we reflected this graph over the line y equals x, and the point 1, 0 reflects to 0, 1, and the point 4, 2 reflects to 2, 4, and we also saw that the point 2, 1 reflected to 1, 2. Now, is there any function that is equal to its own inverse? Yes. If f is equal to f inverse, then f of x is equal to x. We can think of several functions that have this property. The identity function does, and so does the reciprocal function, because 1 over x equals x. Any function f of x which is equal to c minus x, where c is a constant, is also equal to its own inverse.